Okay, so we're in section 1.4 from Al Grosch's Developmental Math 2 class notes. We're going to talk about adding, subtracting real numbers here. How do we add real numbers? So another name for real numbers, and what we're going to talk about, is sign numbers, positive and negative numbers. So we're going to look at, first we have a number line here, showing us how the positive and negative numbers line up. Positive numbers here to the right, negative numbers out here to the left, and they go in the opposite direction. So whereas positive 1 is to the left of positive 2, negative 1 is to the right of negative 2. They run in opposite direction. So we're going to add two numbers with the same sign. This is the same thing you learned in grammar school. 10 plus 3 is still 13. That's positive 10 plus positive 3. Positive 15 plus positive 12 equals 27. When you add negative numbers, it's telling you to add them and keep the same sign. So really, what you're going to have here is negative 2 plus negative 3. Two negatives give you negative 5. Negative 1 plus negative 7 give you negative 8. So when you're adding two negative numbers, you add them to keep the same sign. When you add two positive numbers, you add them to keep the same sign. So we're going to practice on these examples a little bit. The first thing we say is we're adding negative 22 and negative 13. They're the same sign. So we add the 22 and the 13, which make 35, and we give it the same sign. We're going to add negative 1.23 plus negative 2.45. So we're going to add them. And of course, to add decimals, you line up the decimals and bring down the decimals straight down and give it the same sign. So we have negative 3.68. We're going to add negative 1/4 to negative 1/2. And again, they're the same sign, so we know our answer is going to come out negative. But to add 1/4 and 1/2, they have to have the same denominator. The common denominator for 4 and 2 is 4. So this one doesn't need to change, but this one does. Remember, you're talking about multiply when you change denominators. 2 times what makes 4? 2 times 2 makes 4. So we have to do 1 times 2 on the top. So we're adding 1/4 to 2/4, and that makes 3/4. But of course, we were adding two negative numbers, so this becomes negative 3/4. All right, on the next page, we're going to talk about adding two numbers with different signs. This is where some students have a little bit of difficulty. So I like to think about the positives and the negative numbers as two little armies that fight against each other. Each one positive guy can cancel out one negative guy. So it's really like they're having two little battles there. If I have 5 negative guys, 1, 2, 3, 4, 5, there's 5 negative guys, and I add it to 2 positive guys, these 2 positive guys can cancel out 2 of these negative guys. So these 2 positive guys cancel out 2 of these negative guys. They kill each other 1 for 1. And what you have left then is 3 negative guys. And that's your answer when you add negative 5 plus positive 2. Over here, this 4 is positive because it has no sign in front of it. So we have 4 positive guys. 1, 2, 3, 4. Going up against 1 negative guy. So what happens is this 1 negative guy can cancel out 1 of these positive guys. So what do we have left? 3 positive guys, and that's your answer here. So if you think about it like that, I mean, it helps with whole numbers, integers. Sometimes with fractions it could be a little bit more difficult, but as you get more comfortable, you'll learn some tips and tricks here. So what do we got? We've got negative 30 guys going up against positive 10. Well, the negative guys have more, so they're going to have the leftovers. But these 10 positive guys will cancel out 10 of these negatives. So we'll have negative 20 left. So the rule is, if you look up here, subtract the numbers, take the sign of the larger number, okay? So subtract the numbers as if they were both positives. So you can look at this. You're subtracting 10 from 30 gives you 20. Take the sign of the one that has most. You subtract the 2 from the 5, that gives you 3. Take the sign of the one that has the most. Subtract the 1 from the 4, take the sign of the one that has the most. So when you get down here to decimals, you know what you're supposed to do because they have opposite signs or different signs. You're supposed to subtract. So we're going to subtract 5.4 minus 2.2, and again lining up leaves us with 3.2, and then we take the sign of the one that had the most, which was the 5.4, and the sign for him is positive, so this is positive 3.2. Same thing here with fractions. We're going to subtract. So let's see, we have 7 over 30 minus 1 over 5, but they have to have a common denominator. It looks like to me the common denominator for 30 and 5 is 30. So we'll change this one. 5 times 6 makes 30, so times 6 on the top. So we have 7 over 30 minus 6 over 30 leaves us with 1 over 30. And what is the sign going to be? Which one had more? 7 over 30 or 6 over 30? So 7 over 30 was more, and his sign was negative. So we're going to give this a negative sign. Now, when you get to something like this on number 4, where you have lots of positives and negatives all lined up, you might be tempted to try and do this left to right, but then you might be confused. Should I add or subtract? Should I put them together, or are they fighting each other? The easy way is to first identify which ones are negative, because all those negative guys will come together and play. They're all on the same side. So we have a negative 20, a negative 12, and a negative 3. They all add because they're all negative. So when we add that together, we get negative 35. And then the rest are positives. Positive 5 and positive 7 make positive 12. At the end, you have one battle going on. So this is where you have to subtract. These 12 guys cancel off these 12 guys. So we end up with 23. 35 minus 12. And a 35 had more, so this is negative 23. Down here we have the same kind of thing going on, but we have some parentheses. We're going to talk about order of operations, but in the parentheses, you should do those operations first. So we'll talk about order of operations, I think, in the next section. So negative 7 plus 8, these guys fight against each other. The 8 wins. He has 1 left, positive 1. Here we have a positive 2 coming down. Here we have negative 13 plus 12. Well, the negative 13 has more guys than the positive 12, and everybody will be canceled off except one negative guy. Okay, now here we could do the same thing. Positive 1 and positive 2 make positive 3. We still have this negative 1. These are opposite signs, so they subtract, and you take the sign of the larger one. Or you could think about it like a battle. Positive 3 guys going up against negative 1 guy. Well, the negative 1 guy is going to cancel off one of these guys, and we're going to be left with positive 2 guys left. Okay, here's some properties of addition. So this is just some explanation of some of the things that happen with addition. The commutative property of addition, numbers can be added in any order. That's just reminding us that 2 plus 3 is the same as 3 plus 2. It doesn't matter what order your numbers are in. The associative property of addition, when we add 2 or more numbers, the grouping of the numbers does not change the sum. So 2 plus 3 plus 4, even though it's telling us to add this first, is the same as if we grouped the 3 plus 4 first. And you can see that if we actually work it out. 2 plus 3 is 5. Then we add the 4, we get 9. Over here, if we add the 3 plus 4 first, we end up with 2 plus 7. They're the same. It doesn't matter which way you group them, as long as it's all addition. When you start putting other operations in there, then it does make a difference. The addition property is 0. When 0 is added to any number, that number does not change. 5 plus 0 is 0. It's 5. 5 plus 0 is 5. Any number plus 0 is that same number, even if it's actually a variable. So it doesn't matter what the number is. The addition property of opposites tells you that The sum of a number and its opposite is always 0. And this has to do with, just like I said before, the positives and the negatives battle against each other. Each one positive can cancel off one negative. So if they have the same number of guys on both sides, they all cancel off, and there's nothing left. So how do we subtract real numbers? Well, I like to say there really is no subtraction in algebra. It's all algebraic addition. And if you think about the sign in front of the number is the sign that goes with the number, and you're just adding positives and negatives. It's the battle of the guys going up against each other. Here's an example, and we talked about this in the last section. This is the opposite of -5. These negatives cancel each other when we have parentheses. So this turns into 5. We can do some of these examples here. The opposite of -7 is +7. The opposite of -g is +g. This one's different because there are absolute value bars. And we have to simplify inside absolute value bars first. So the absolute value of -15 is 15, and then this negative sign on the outside comes down. So this part simplifies to 15, and this negative comes straight down. So this one comes out to be a negative number. So we have change of subtraction types. I don't really like to do this. Some students learned it this way in middle school or high school. I don't feel like, personally, having these two signs is not beneficial. It's actually more confusing than just thinking about everything is addition. Okay? Everything is addition, and the sign is telling you what you're adding. So in this example here, you're adding -5 and -3. Since they're both on the same side, they're going to come together. They're not going to fight, and you're going to end up with -8, which is exactly what the author's method is. So he's just writing it as the addition with the negative sign in front of the 3. You can write it like this if you like. I don't like to write two signs. To me, it's a little confusing to look at. So I just kind of mentally think about, I know it's all addition, and so I just need to simplify signs. For instance, here, we need to simplify these signs so that we know whether this 9 is really a -9 or a +9. This is saying what's the opposite of -9, just like we practiced. So this simplifies to make it 7 plus 9, which of course is just the addition of two positive numbers, which turn out to be +16. So we got a few more examples on this page where we're going to practice adding and subtracting positives and negatives. And again, I don't like to write the double signs, so I'm just mentally thinking this is -10 plus -7. It's all addition. The sign in front of the number is telling you whether it's positive or negative. So since these are both negatives, they come together. They don't fight each other. They come together. They're on the same team. This is going to make -17. This is +50 plus -85. Well, these are opposite signs. So these +50 are going to cancel off 50 of these 85, which is going to leave us with -35 because we subtracted those 50 that got canceled off. And then we took the sign of the larger 1 because there were more negative guys to start with. All right. When we get down into fractions, it gets a little bit more complicated, but we can still simplify our signs here. This is the opposite of -2/9. So this is really turning into 1/3 plus 2/9. These are both positives. The only challenging part here is that we have to get a common denominator. So 1/3 being added to 2/9. What's the common denominator? Is 9. So this one doesn't need to change. How do we change thirds to ninths? Remember, it's 3 times what makes 9. So 3 times 3 makes 9. So times 3 on the top gives us 3/9 plus 2/9 makes 5/9. And it's positive because all the negatives were gone once we simplified. All right, over here, we kind of did one of these before. We're going to first identify where are the negatives. So this 7 is negative, this 4 is negative, but this 10 is positive. This needs to be simplified before we can decide whether it's positive or negative. This is saying the opposite of negative 5. So that really is positive 5. So where are the negatives? So we've got negative 7 and negative 4. Those are the only negatives. When we add them together, we get negative 11. The other guys are positive. We have positive 10 and positive 5 make positive 15. So this is what we end up with. Negative 11, positive 15. These are opposites. They're going to fight against each other. The positives are going to win because they have more guys. But when these 11 cancel off 11 of these, there's going to be 4 left. And of course, they're going to be positive. All right, we have a word problem down at the bottom. I like the word problem, so we're not really going to skip over them. Water level. In 1 week, the water level in a storage tank went from 25 feet above normal to 12 feet below. Find the change in the water level. Find the change always means subtraction. So we're going to draw a picture of what? A storage tank. Okay, there it is right there. It's a storage tank. The first thing we're going to identify is this is the normal level in the storage tank. So that's 0. The water in the tank went from 25 feet above normal, so this is a positive 25, to 12 feet below normal. So this is a negative 12. Find the change in the water level. Find the change always means what's the difference between the two. It's a subtraction operation. Always. Find the change. So we're going to subtract 25 minus negative 12. Well, what happens when we subtract minus a negative 12? This is saying the opposite of negative 12. That's the minus and the negative sign mean the same thing. So this simplifies to be a plus. So we end up with 25 plus 12, which is 37, and the units were feet. Does that make sense in the context of this question? Did the water level actually change 37 feet? Well, if you think about it, from positive 25 to 0 was a change of 25 feet, and then from 0 to negative 12 was a change of another 12 feet. So yes, it changed 37 feet.